Great, welcome people. Troy or Stephen, can you see my screen, see the NEWMOA website? Excellent, great.
Yes.
So welcome, my name's Jennifer Griffith and I work at NEWMOA, which is the Northeast Waste Management Officials Association. We are an interstate association of the 6 New England states, New York and New Jersey. The solid waste programs, the hazardous waste programs, the pollution prevention and toxics reduction programs, and then also the waste site cleanup programs in those 8 states work together through NEWMOA. And the priority for the waste site cleanup program is training. And so that's what we are doing today. So I welcome everybody, and we have 2 great presenters. We've got Stephen Jackson and Troy Strock from US EPA to speak with us about analytical methods for PFAS, sort of what's out there, what they're working on, when it might be appropriate to use one or the other, or benefits and limitations. But I'm starting now because I wanted to let everybody know presentations, a PDF of the presentations from today will get posted on the NEWMOA website. If you want to learn more about NEWMOA, it's just NEWMOA.org. But you would go to find information. You can come to events. So I'm just going to show this quick. And our events are very forward-looking. So here's all the different webinars that are coming up that are available for people to register for. This is today's, but eventually today's webinar, so we still have several more in this series, and here's one on a solid waste topic, if anybody's interested. And this other project here is another solid waste little project that I've been working on. Doesn't have a lot of meat to it, but if you want to attend that one, you can as well. But when you come here in the future, today's webinar you won't see because it's in the past. So you got to look, this little arrow here is like a key item. So you click on the back arrow.
I'm not seeing anything changing on your screen. Troy, are you seeing anything change?
No, it's just a home screen, it looks like.
Okay, yeah, I'm just seeing you're leading the Northeast to a sustainable waste-free future tab here.
Oh goodness, all right, well, I've been clicking away here, so.
I picked up on that.
That's odd. Okay, well, maybe my website's frozen. But you're hearing my voice. Are you seeing me still?
You can see you.
Okay, and I'm not frozen in some horrible way. All right, well, that's very strange, but all right, well, okay, forget the demonstration of the website. So the presentations will get posted. I will send a link around to this event to everybody that's on the webinar today after the presentations are posted. We have a lot of people on the webinar today, so we'll be doing questions. You have to type them in. So in your GoToWebinar control panel, there should be a section for questions, and you can type in questions at any point, and I will ask them later. One thing that we're doing with this webinar series that's new is we did get the Massachusetts Licensed Site Professional approval for continuing education credits for these webinars. So if you do want the Licensed Site Professional credits for these webinars, you got to do a few things. One, you got to be on the webinar for the whole time. You got to stay till the end. You can't do anything else during the webinar. So, and this is just information for everybody. GoToWebinar can tell if you're doing something else on your computer and the webinar is not like the top screen. So if you're checking email and typing emails, the GoToWebinar knows that. So if you want the LSP credits, I can tell, and I can't give you credits if you're doing other stuff. So you need to keep this webinar at the top level of your screen. We are going to have to put some poll questions during the webinar I'm sorry to everybody else, but we're going to have to do a few of those. And if you want those LSP credits, you need to answer all the poll questions. And then also at some point during the webinar, you need to type a question in, some sort of question. Try to have it be a relevant, question that you really have about one of the presentations. And then I did put in the registration, eventually I put in a question that if you want the credits, you could type that in when you're registering. But if you registered for this webinar a long time ago, that wasn't in there. So you need to let me know if you want the LSP credits, because I won't be able to know automatically that you need them. So with that, let's see. Maybe I clicked the wrong thing. Are you seeing the screen now?
It worked.
Okay.
Yeah, now you're on the events tab.
All right, I must have clicked a button. So anyway, I was just saying this little back arrow is key here, because that's how you can find events that have happened in the past rather than the future forward that you land on right at the beginning. So and so I'll just show real quick a past webinar so you can see. And they also go in reverse order. So the most recent ones down here at the bottom. This one I don't have one of the presentations posted yet. Hang on, I'll put this one. Oops. So you can just see here we have the presentation posted. So that's how you can find the presentations afterwards. So with that, I'm going to remind people, we will post the presentations on the NEWMOA website. Type in your questions at any point. And with that, I'm going to introduce our first presenter, which is Troy Strock. He's from US EPA. He's the organic methods lead for the solid waste for the SW846 methods program in EPA's Office of Resource Conservation and Recovery, ORCR. Prior to coming to, I forget how to pronounce that acronym, he worked for 2 years at the contract laboratory program at EPA's Office of Superfund Remediation and Technology Innovation, and for 14 years in the EPA Region 5 laboratory in Chicago as an organic chemist. So he knows a lot about methods and chemistry. He holds a bachelor's degree in interdisciplinary science and biology and a master's degree in soil science from Purdue University. So with that, I will stop talking and get rid of my camera and take it away, Troy.
All right, thank you. So today I'm going to say informational presentation about EPA PFAS analytical methods and aqueous and solid matrices, both methods that are out there and some other methods that are in development that we're working on. And so I appreciate you all tuning in to listen. I just want to, for my first slide is a disclaimer that says, I do not represent an official policy or view of EPA. So if I mix something up, please don't tell my boss. And by the way, I have a couple of instruments that I show in here, and they not endorsing any products, but just giving some examples. Some instrumentation has been used for some of these tests. So thanks. So briefly, I want to give you some background about the EPA program offices and methods programs, talk about some recent PFAS actions, related actions, including rulemakings, guidance documents, Office of Science and Technology Policy, interagency strategy, and then I'll talk about a little bit about some of the published EPA PFAS analytical methods and drinking water, wastewater, and solid waste matrices, and then talk a little bit about some of the PFAS analytical methods that are under development, including targeted analytical methods, non-targeted analysis, which is more like a framework really than a specific test method, and then I'll talk a little bit about some aqueous leaching methods we're working on. So first of all, just to give you a big picture view of what is the EPA and how is it organized. EPA's got a bunch of big offices, a bunch of offices in them, okay? And so shows a picture of all of the EPA offices. The including the Office of the Administrator, but also, the offices that are each of the EPA program offices are located in. So our big umbrella office that I work in is the Office of Land and Emergency Management, and it has several program offices in it. And I'll talk more about them, but the offices that publish methods are the ones in blue. So that includes the Office of Air and Radiation, which Dr. Stephen Jackson will talk about. Also the Office of Water, which has the Clean Water Act methods and the Safe Drinking Water Act methods program. And then the Office of Chemical Safety and Pollution Prevention and the Office of Research and Development also publish methods. And I apologize, I think Dr. Stephen Jackson is in Office of Research and Development and not in OQPS. So I just wanted to say that each one of these offices, each one of these big EPA offices has a number of program offices inside of them. So in the Office of Land and Emergency Management, I think we have 11 program offices, something like that. So we have the Office of Resource Conservation and Recovery, which is where I work. And so this is a waste program. We make basically the regulatory infrastructure for how solid waste and hazardous waste is managed in the US. And then we also have the Office of the Superfund Remediation and Technology Innovation. So that's the Superfund program. So they're cleaning up hazardous waste sites, former industrial sites. And we also have the Office of Emergency Management, the Office of Underground Storage Tanks. Basically all the land cleanup programs are covered under this big umbrella office. And so the SW-846 compendium is the official collection of test methods for compliance with the Resource Conservation and Recovery Act. And so this is a compendium of test methods that I work with, and we're charged with keeping up to date. And it includes more than 200 test methods and guidance on project planning, sample collection, quality assurance, and it's really widely used for environmental sample testing, and the data is used, I would say, generally for risk management, to assess exposure, to assess contaminant transport, to look at contaminated sites, to do characterization of contaminated sites, to make sure that the sites are cleaned up and they meet the remediation goals and so on. So they're used for a wide variety of purposes. But some of these, a handful of these methods are incorporated by reference in the RCRA regulations, and those are method-defined parameters. And so those methods are either required to be used to comply with RCRA regulations, or we consider the results of these methods to be definitive for the purpose of demonstrating compliance with the regulations. But the vast majority of SW-846 methods are non-regulatory. We publish them as performance-based methods. We don't require them to be used. We say any reliable published method can be used for demonstrating compliance with RCRA, as long as it's acceptable to the end data user and it performs acceptably. And so these methods are really used by the OLM program offices. Some other EPA offices are used by state and other federal government agencies, foreign governments, commercial and government testing laboratories, and industry for like I said, for risk management purposes. So I just made a list of a few recent EPA PFAS rulemakings and guidance documents that you might already be aware of, and I organize them under these categories. So one of them is the Resource Conservation and Recovery Act. We recently proposed to adding a handful of PFAS to Appendix 8, which is in 40 CFR Part 261, which is a list of hazardous constituents. So this rulemaking does not make PFAS to hazardous waste, but hazardous constituents, they can be included in RCRA. They call them corrective action permits. So hazardous waste management units, such as a hazardous waste treatment, storage, and disposal facility, generally they're permitted, and when these chemicals that are on this Appendix 8 can be included in those hazardous waste permits, and they can be subject to cleanup if a facility has a release from their site. So if a regulated hazardous waste management unit has a release, and so that's the purpose of this rulemaking, and it was proposed in February 2024, and so this is it's moving along. We've got the public comment period is closed already for that, and also in our office we propose to clarify that this, for the purpose of a RCRA corrective action, which is again, regulated or permitted hazardous waste treatment, storage, and disposal facilities, generally the statutory definition of hazardous waste as opposed to the regulatory definition applies to corrective action of releases from solid waste management units. And that is just to say that the regulatory definition is a little bit more narrow than the statutory definition, but our longstanding policy is to use the statutory definition for the purpose of corrective action for cleanup of releases from hazardous waste management units. So that's already public comment period's already closed on that one too. So we're in the process of adjudicating comments for both of those. And then the Superfund program, they designated PFAS and PFOA as circular hazardous substances, and that rule was final in July. And that rule makes PFAS and PFOA, first of all, subject to reporting if they have a release above a de minimis amount in I think in a 24-hour period. And it also makes the PFOA and PFAS subject to cost recovery if they're for cleanup at contaminated sites. The other thing that I'm not sure that fits underneath the CERCLA, but was led by somebody in OSREADY, was this update to the PFAS destruction and disposal guidance. So it was an interim update. It's not final yet. But it provides some best practices about how to manage hazardous waste. What are some of the treatment technologies that we know of, and what's under development that are effective. And so this one is actually the notice of availability for public comment was released in April. The comment period for this interim guidance, update to this guidance, closes on October the 15th. And so you still have opportunity to read through this guidance and make comments on it if you'd like. And the link to this Federal Register notices actually has a link to where you can submit public comments. And the other thing I'm sure you were aware of, but the Safe Drinking Water Act, they published a national primary drinking water regulation that established maximum contaminant levels, so maximum concentrations for 6 PFAS in public drinking water systems. And that rule has a 5-year implementation timeframe. But the Federal Register notices are all linked here if you want to read, want to look for more information about any of those actions. So another thing that's happened recently is also, the White House Office of Science and Technology Policy put together an interagency work group, the PFAS interagency strategy team, and they put together a PFAS Federal Research and Development Strategic Plan. And this was just released in August of 2024. And so this document, it's basically collates some of the, the data gaps that the different federal agencies identified in terms of, exposure, risk, prevalence and occurrence in the environment, in products and foods and so on. And it put together a strategy for how to address those data gaps. And so, in this document, there's a link down here below. But in this document, under strategy 2, it's basically where we lay out what are the measurement challenges that we have, and where and how are we going to address them with publication, development, and validation and publication of new test methods. And so we have, a few categories, which is sort of the targeted analytical methods, non-targeted analysis, which I'll talk a little more about, these aggregate or class-based methods for PFAS testing as a collective, and then also some aqueous leaching methods are identified as method development needs under strategy 2 under these different research objectives. And there's a ton more information in there, but just to give you a primer, this is some of the motivation, I think, for us to develop, validate, and publish new test methods. So I sort of talked about this, but some categories of PFAS analytical methods include the targeted analytical methods, these aggregate or class-based analytical methods, the non-targeted analytical methods, and aqueous leaching methods. And so the targeted analytical methods are really for quantitative analysis of chemicals, what we have a certified reference material for. We know what the concentration is. We have a reference to compare the signal to and an unknown, and we can make a quantitative measurement of these various specific chemicals, qualitative and quantitative identification, or qualitative identification, quantitative analysis. It's generally not suitable for detecting PFAS that are not on the analyte list. And so there's a lot of PFAS, a lot more PFAS that have been used in products and were probably released into the environment than we can measure with these targeted methods. And so that's one of the reasons where we get interest in aggregate or class-based analytical methods, which basically can measure a sum of fluorinated chemicals through a couple of different techniques I'll talk about. They generally can't identify specific chemical structures, but some of them can hold on to some structural information. And we also have non-targeted analytical methods, which is using generally it's a liquid chromatography or gas chromatography, high resolution mass spectrometry, tandem mass spectrometry to look at basically to use high mass resolution to identify molecular formulas of different mass fragments and piece together what is the structure of this chemical. And we can also compare spectra to a database of knowns and so on. But generally it's qualitative or at best semi-quantitative, that analysis approach. And then we'll also talk about aqueous leaching methods. So it's sort of evaluating mobility in groundwater, making better models for subsurface transport, and evaluating immobilization strategies prior to trying to do this like in situ stabilization of some field contamination, where we basically could make a contaminated source area in the soil into a big concrete block and limit diffusion out of it, for example. So the PFAS analytical methods that are published, that are available currently in aqueous and solid sample matrices include a couple of Safe Drinking Water methods, Safe Drinking Water Act methods, 533 and 537.1. And those are targeted analytical methods. They were validated in drinking water. They are, they have a defined list of target analytes. They have required quality control criteria that are generally pretty tight. Drinking water matrix is generally pretty straightforward to test, so it's usually they don't encounter a ton of matrix effects. We also have our office published in 2021. We published a couple of analytical methods for a sample preparation and analytical method for non-potable water. I'll talk more about the Clean Water Act. The Clean Water Act methods program just published a couple of analytical methods, including method 1633, which is a targeted analytical method in non-potable water and solids. That's what it was validated in. I'll talk more about that one. And method 1621, which is adsorbable organic fluorine, and that's an aggregate, like a class-based analytical method that I also have another slide about. So the Clean Water Act method 1633, this was just published. It was finalized in, I want to say it was January, February, but it is maybe the most validated method of all time. They included 8 different matrices, both aqueous and solid matrices, some really challenging matrices, landfill leachate, biosolids, they really put this method through the ringer, and it actually works very well. And so the aqueous samples are extracted with the solid phase extraction and using a weak anion exchange sorbent, and solids are extracted with a basic methanol, and then the extracts are cleaned up through non-porous graphitized carbon, and the solids get diluted into water and get solid phase extracted, and then get subjected to the graphitized carbon cleanup. And then the extracts are analyzed by liquid chromatography tandem mass spectrometry, which is the common method, I think, for analyzing the organic acids. So there are 40 target analytes in this method and 24 labeled internal standards. They use isotope dilution calibration, and their validated limits of quantitation are very low part per trillion concentrations for water, subpart per billion concentrations for soil sediment, and then this should say fish tissue, I think, for the, I don't know what that solids is about. It really should say fish tissue there. Anyway, I just wanted to point out that Adrian Hanley is the Clean Water Act methods team lead, and he's the contact for this method. So the SW 846 methods 3512 and 8327. So rather than solid phase extraction, the 3512 is a methanol dilution sample preparation method. So it's aqueous sample is diluted 1-to-1 with methanol. It's filtered, you acidify the sample, and it's ready for analysis. And so this sample preparation method is rapid. It's very simple. It's very straightforward. There's few opportunities to contaminate your sample, and there's few opportunities to lose chemicals between the your sample container and the LCMS instrument. But it is a near direct analysis method. There's no concentration step, which means that the sensitivity may not be it may not have as high a sensitivity as using a solid phase extraction method where you have a concentration step. I have worked with a couple of laboratories that are concentrating their extracts that are reporting limits of quantitation for using these combination of methods to 2 nanograms per liter. So it is possible to run this method very sensitive, but it is generally speaking, the laboratories establish and verify their own limits of quantitation. And so if you're interested in knowing what can labs achieve, you might have to reach out to individual labs to find out what are the limits of quantitation that they've established and can routinely meet in their laboratory. So again, this is a LCMS-based method. The validated limits of quantitation in the method validation study were 10 to 20 nanograms per liter, and so we're actually in the process of revising these methods to update them. The ASTM just finished a multi-lab validation study for D8421, which is essentially the nuts and bolts of those methods are the same or very similar to 3512 and 8327, but they validated in all the same matrices that they did for the Clean Water Act methods, and they includes the same number of target analytes. They even added a couple of the ultra short chains, so that would be perfluoropropanoic acid and this trimethylsulfonyl bis trifluoromethylsulfonylamide. So there's a couple of ultra short chains in there, and so this actually so with this validation study, we're going to use to expand the range of target analytes that are in the determinative method and add some performance data and add isotope dilution calibration as an option, and we're going to use some of the information from 1633 to do that too. And so the method developer for these methods for 3512 and 8327 and for ASTM D8421 was Larry Zintek, and he works in the Region 5 lab. So the next method I'm going to talk about is the Clean Water Act method 1621, adsorbable organic fluorine. And so this method is a combustion ion chromatography method. So this is, basically taking a water sample. So it's only for aqueous matrices. That's how it was validated. And it was developed and validated in wastewater. Okay, so they're taking a wastewater sample, they run it through a graphitized activated carbon and sorbent. And so then they sorb the PFAS or the organofluorine containing chemicals to the carbon. And then they use a dilute nitrate rinse to rinse through the fluoride, the inorganic portion of the fluorine. Then they take the sorbent and combust it and run it through an ion chromatograph, and then use the UV, I think, as a detector. And so this is basically an aggregate method, and whatever is in that sample that's fluorinated that sticks to the carbon will end up in the extract and be analyzed and be combusted and analyzed by ion chromatography. So one of the limitations of this method is the background in the activated carbon is there's some fluoride background in activated carbon, and it's a little bit hard to get it out. And so some of the background contamination problems they had resulted in a little bit higher limited quantitation, and that I think in the method it says 5 micrograms per liter is a reasonable expectation based on their multi-lab validation data. And Becca Burkett in the Office of Water is the project lead for this one. So here's a couple of drinking water method development projects that the Office of Research and Development, Office of Water are working on. First of all, to address the problem of that fluoride background in the activated carbon, Dan Tettenhorst is working on method development. So where they're using, actually basically doing that wax solid phase extraction that's in method 533 or in method 1633, and then they're taking the extract and combusting that. So it's not using activated carbon, but using a weak anion exchange sorbent, and like that they can get around the problem of the background that they have with the activated carbon. And so Dan's working on this development project, and he's working on optimizing the separation of the inorganic and the organic pools of fluorine, and it's some of the challenges are, really just the ultra short chain PFAS breaking through the sorbent. You can't recovery correct with internal standards using the EOF method the way that you can with the targeted analytical method. And so if you have breakthrough, you basically just have loss. And so there's some PFAS that don't stick as well to the weak anion exchange sorbent, and that's also true of the graphitized carbon. But it's, still they're going to get rid of this background. I think it's really going to be more sensitive than the method 62 and 21. And the other thing that Dr. Will Adams is working on is in the Office of Water is drinking water method for the ultra short chain PFAS. So this is C1 to C3. So the water solubles, and he's working on a couple of different projects. One of them is solvent dilution and direct injection or direct aqueous injection, or inline solid phase extraction, where it concentrated on basically on a pre-column on the liquid chromatograph. So there's contact information for those guys down there. And then the Office of Research and Development is also working on an analytical method for the neutral semi-volatile PFAS precursors, including the fluorotelmer alcohols and acrylates in aqueous and solid samples. And so they're using a liquid-liquid extraction or liquid-solid extraction with ethyl acetate. And then they use positive chemical ionization, GC, gas chromatography, tandem mass spectrometry, that's very selective and sensitive for these target analytes, and they can get down to detection limits with single lab of sub part per billion concentrations, not as sensitive as the LCM SMS methods, but still very sensitive. And I'm hoping to take this developed method and put it through validation and publish it as a standardized test method. So I just want to say a word about non-targeted analysis. This is just a framework for identifying non-target PFAS in environmental samples. And there's a link here to this BP4NTA, which is best practices for non-targeted analysis. This is a collective, a group of folks in EPA, other federal agencies, and in industry who are working on the non-targeted analysis, tools, providing tools and guidance about how to use non-targeted analysis, how to interpret the data, and so on. And so I just wanted to say there's a link here if you're interested in more information. Probably should have added James McCord as the contact for this group, but definitely he's involved in it and one of the leaders of it. And so he's a guru in non-targeted analysis at EPA. And so if you're interested, there will be a link in this presentation you can follow for more information. And then, we're also working on the total oxidizable precursors, which is an aggregate or a class-based analytical method for PFAS precursors. And so it's a pretreatment method where we're using alkaline persulfate oxidation to convert PFAS precursors to perfluoroalkyl acid. So we're trying to take these PFAS precursors that we can't measure with the targeted analytical methods and convert them to the perfluoroalkyl acids that we can measure with these targeted methods. And so we're working with a pretty good group of commercial labs and universities, some other federal agencies on this. And some of the challenges we have are trying to make sure that we oxidize everything efficiently that's in the sample. All the precursors get oxidized to perfluoroalkyl acids we can measure, and some of the challenges including like dissolved organic carbon interfering with the oxidation, with the quenching the radical formation essentially, and making it so that we don't oxidize all the precursors that are there, and we end up with some residual left over. And also, looking at the difference between heat activated and UV activated oxidation, there are some substantive differences there that we may be able to pick one or other as ideal. And then we're actually working on incorporating a surrogate to monitor the oxidation process so that we can build some quality assurance into this method. And also, in the process of looking at these alternative analytical methods, these new analytical methods where we can look at ultra short chain PFAS, we can monitor, we can do a better job of measuring some of the products that we're making with this top assay by monitoring for the ultra short chain transformation products. And then we gotta control for volatile loss, and we may need different process for solids than for aqueous samples, whether it's direct oxidation or extraction followed by oxidation. So Moha Ibrahim is the project lead for that one in the Office of Research and Development, and his contact information is there. And there's an article down here too if you're interested in learning more. So here's my poll question. I said this earlier, but how many EPA headquarters offices publish test methods?
Okay, so
Did I run out of time
you
yet?
can use your cursor and choose the one that works, and we'll just let a bunch of people vote, and then we'll particularly if you want the Massachusetts licensed site professional continuing ed credits, you must answer this. It's optional for everybody else, but can be kind of fun, because if you remember in the beginning, he had some boxes, but that was a while ago.
I said a lot since then.
So,
Oh, sorry, oops.
okay. So let's see if we can get a couple more people to vote here. All right, well, it's been a minute, so I'm going to close this poll. And Troy, what's the answer?
Okay, so there are 5 EPA headquarters offices that publish test methods, but there are really 3 main offices that really have methods programs that I'm aware of, and the answer really could depend on how we define method and how we define publish. Because the Office of Research and Development is publishing research all the time that includes test methods that have been developed and optimized, but not necessarily multi-lab validated and not necessarily EPA's test method, official test method. So some of it may depend, but there's some links down here to learn some more about those methods programs if you're interested. So I know I'm pushing the time, so I would just want to say briefly that when it comes to aqueous leaching methods, my office, and my program office, so the RCRA program, and also the Office of Land and Emergency Management is frequently interested in evaluating mobility of contaminants from contaminated waste or contaminated source area, to try to manage risk, and so we're working on these methods, these 4 methods, collection of 4 aqueous leaching methods were published validated and published for inorganic chemicals in 2019. I think we published all of these methods, but we're working on they're multi-point test methods, and we're working on adapting them to PFAS. And so we have 2 batch methods, and we have 2 dynamic leaching methods. So the batch methods, they vary the solution pH, and they vary the liquid to solid ratio, where the dynamic methods, there's a column test, and then there's a tank leaching test that look at release of contaminants over time. And so these are the data we can use to better model leaching behavior and optimize, evaluate, and optimize like reagent mixes for in situ stabilization before we deploy it in the field, because it can be very expensive to do to deploy these field-based like in situ stabilization remedies. And so if we can do a better job of optimizing that in the laboratory, we can be more efficient if we spend money. And so the methods are working on validation studies for the 2 batch methods and the column method right now. And then we're still working on development of the semi-dynamic tank leaching method. We're looking at 2025, probably by the end of 2025, to release these first 3 methods for public comment. And then the semi-dynamic tank leaching tests will be for monolithic and compacted granular materials will come after that. So these aqueous methods, the batch methods, the problem with them is, they're great because you can do it in a day. They're small, they're relatively small scale. It doesn't take a lot of fancy equipment, but they do have the tendency to, because they're very rigorous mixing, they do have the tendency to potentially overestimate in situ leaching. Some of the challenges we ran into in these pictures I showed you in the upper right over here are, how colloids can be more challenging at a higher pH than at lower pH, and we have to avoid filtration because we can lose PFAS in the filters, and we can contaminate the samples with filters. And so the solution we have is to centrifuge the samples to do the liquid solid separation to aid in that, and then to measure the aqueous concentration, because that's what we're worried about being mobile. And so I have some data in here to show some examples of some PFAS leaching from different. These are different AFFF contaminated soils, and this is a batch method. So you're looking at leaching as a function of pH, solution pH, and then there's another one that shows a column test that shows leaching as a function of pore volumes eluted through the column. And so it's just some more data for you to get a feel for what do we see as outputs of these methods, and we have more guidance on our website in terms of how to use the data. And so here are my here's my contact information and contact information of my manager, just in case you have more questions or need more information. And feel free to click around on our website to see if you're sign up for our mailing list. Ask technical questions about methods. That's all I had.
Okay, well, thanks, Troy. And I feel like I've just been drinking from the fire hose here. So
I know it's a lot, right? It's a lot. I know. I apologize.
yeah. So, but we do have a bunch of questions, and I guess I'm going to ask this one because it's a leachability one. So,
Okay.
so how would you deal with like more solid stuff that's not soil, like plastic, like people want to test synthetic turf? That will UV degrade and can enter the groundwater. So is TCLP extraction sufficient? Or is there some other leachability test that's out there or in development?
So TCLP has it has a filtration step in it, right? And so, there's a glass fiber filter in there, and that is the place where, I think it's not going to quite work you're going to end up losing stuff's going to stick to the filter. The Office of Research and Development has done some research with adapting the SPLP, so that's a synthetic precipitation leaching procedure. That's method 1312 to PFAS leaching, and they use centrifuging instead of filtration for liquid solid separation. But it's not perfect, right? Because you end up with, when you centrifuge, you can end up with some very fine particulates, still suspended in solution, and so you can end up entraining them in your analytical training and measure those PFAS as being in aqueous solution when in fact they're stuck to solids. And so that's one of the limitations of it. But SPLP, that method 1312, and the adaptations that Office of Research and Development made to it, is really very similar to the method 1316A that we're working on. The only difference, real substantive differences, is a liquid to solid ratio as 20:1 in SPLP, and so where the 1316 says it goes from, I don't know, 0.5 to 10 or something like that. But you could use a method like the 1316 or a method like a modified version of the SPLP method to evaluate aqueous leaching of from a solid other than soil, and make sense of the data. But I would say, it depends on what it is you're trying to do with the data. What are your some of it comes back to your data quality objectives. Are you trying to show a regulator that this is not an issue? And if so, then you really want to put together a project plan and say, this is how we're going to do this test. Do you agree that this is acceptable? And so some of it could come back down to what are your goals?
Right. Okay. Okay. I think we'll do a couple more and then we'll have to switch. But has PFAS been added to the OSR request form the requirement to report whether waste contains a regulated hazardous substance, pollutant, or contaminant. Do you know about that?
That is not something I'm familiar with. I don't know about that form. I don't know, for RCRA, most for RCRA subtitle C, so that's RCRA hazardous waste regulations, most US states are authorized to implement RCRA regulations in their states. And their regulations can be more stringent than the federal RCRA regulations. So generally speaking, when we get questions about, regulatory questions about RCRA, a lot of times we have to push to the state as the front line to answer those kind of questions, because they may have regulations that are more stringent than RCRA. But right now, under the current federal RCRA regulations, PFAS are not identified as a hazardous waste. And so if it's a waste management question, then federal RCRA regulations don't address PFAS at this time. But the states may. And so as far as the Superfund program and their rules about hazardous substances, release of hazardous substances, I don't know about that. That'd be a better question for the Superfund program.
Okay, and then actually 2 different people asked very similar questions, which are there any field sensors or any water sense, any field work screening methods, I guess, for water?
That's a great question. You know what? I think that's one of the research and development needs. It's identified in that document. And I think I've seen some presentation abstracts about that. I was at a couple of conferences I've been to, but I don't know very much about it. And so I would say, that might be a better question for the Office of Research and Development, who might know more about developing technologies and so on. I just don't think I'm really qualified to answer.
Okay, here's one that you might know, and then I'll move on. Why does EPA 1621, so hopefully you know what that one's about, not require the rinsing of sample bottles given the absorption of PFAS compounds, I think has been reported to
yeah, it's a great question. Some of those PFAS don't stay in aqueous solution, and so this is something that I think that's not the only issue with the method. They have issues with breakthrough too. Because some of these matrices can be really gunky. Can have a lot of organic matter in them, and that can that has the potential to lead to a greater level of breakthrough on the sorbent. And also they only tested through perfluorobutanoic acid, so they didn't test the shorter chain PFAS target analytes. They did a lot of testing, but they didn't test everything that we have a targeted analytical method for. And so sorption of the container and breakthrough on the sorbent, those are a couple of the limitations of the method. But I know they're aware of them, and so they may have a plan to make some updates to the method eventually, but I think they decided that it was useful for its intended purpose. And it can measure the chemicals that are generally going to end up in the water column, because if they don't stay in aqueous solution and you're losing them to the sample containers, they also may not be coming out of a wastewater treatment plant. And so but that is really a good question for the Clean Water Act methods folks. Becca Burkett would be absolutely the best person to answer.
All righty. Well, thank you so much, Troy. And we can come back. There's a couple more that we didn't get to if there's time at the very end. But I think in the interest of time, I'm going to move on to our next presenter, which is Dr. Stephen Jackson. He's worked as a chemist in US EPA's Office of Research and Development since 2019. In that time, his work is centered on developing sampling and analytical approaches for emerging contaminants of concern, which certainly includes PFAS. Additionally, he's interested in using non-targeted analysis techniques to gain a more comprehensive understanding of source air emissions. He's got his bachelor's degree in chemistry from Hendrix College and a PhD in chemistry from Vanderbilt University. So, with that, I'm not going to turn it over to Troy yet because we're going to do another poll quick. So this is a silly one, but where does Stephen Jackson work? Does he work in Massachusetts, at USGS, CDM Smith, or US EPA? So this is mostly just for those Massachusetts LSP credits. You got to vote. You got to vote for something. So I'll just let a few more people vote. This is just a silly one to verify people are here and listening. And I'll let it go another 10 seconds or so. A few more people want to vote, that would be great. All right, so I'm going to close that one, obviously, or hopefully, obviously. I just introduced him. He works at US EPA. So with that, Stephen, take it away.
All right, thanks. Oh, Stephen, you're muted. I don't know what happened. Sorry. I think I might have clicked on the wrong thing, but now it's okay. There you go. Okay.
Sorry about that.
Yeah, sorry. Said I couldn't unmute myself. So, all right. So does the slide look okay to you, Jennifer?
Oh, I hesitate to push any buttons, but yes, it looks good. Take care.
All right, great. All right. Well, thanks, Jennifer and NEWMOA for the invitation, and thanks to Troy for the great first half of the session, and I'll try my best to keep up the momentum here. But for my part of the talk, I'll be discussing specifically the stationary source methods for measuring PFAS air emissions that we've developed in EPA's Office of Research and Development over the last few years. There we go. Okay, so a very brief outline, basically just here to keep me focused when I'm putting this together, but also to highlight for y'all that for today's talk, I'm going to try to discuss more of the intent and applicability of the methods, as opposed to getting into the nitty-gritty details of how you collect or analyze the samples. Now, if that's the level of detail you were hoping to hear, please feel free to contact me later, and we can really dig into the details another time. And I'd be happy to do that. And then another thing that I wanted to touch on really briefly, which is one slide at the end of the talk today, is something that I get a lot of questions about now, is what happens if you want to measure PFAS in air from something other than a traditional stack or duct. So that could be some of these new destruction technologies without flows that are adequate for running, say the OTM 45 train, for instance, and then hopefully leave some time for questions. Okay. So first, to explain exactly why we need methods to accurately measure PFAS and source air emissions, we really have two driving motivations. One, we want to develop methods that will allow for comprehensive source characterizations. So we want to know with confidence what's being emitted and at what quantities from a given source. And then two, there's a major focus on evaluating the effectiveness of PFAS destruction technologies. And to do that, you need to know how much of a given species is going in, but then also how much is going out. And sometimes those influence or effluents are in the gaseous state. So again, we need to develop these measurement methods. So then as these methods are used and the data is generated, that data may be used to support state regulatory processes or inform a federal decision. Okay, so like I just mentioned, with the two driving motivations of our source characterization work and destruction assessment, we've really focused our efforts on developing methods that will best characterize industrial sources and destruction technologies. And that's not to say that There are other routes of PFAS emission into the air. You know, some of them are mentioned here in point 3, but we're primarily focused on industrial sources, whether those are PFAS producers or industries that use PFAS to develop or alter other materials or products, specifically through a thermal process that may produce volatile emissions. For example, the schematic, I think y'all can see my pointer here, but the schematic here in the bottom right is of a glass cloth or fabric going through a PFAS containing dispersion that is then passed through a series of ovens to thermally adhere it to the cloth. And so we anticipate that there could be volatile PFAS emissions there as well that would be counted in that industrial source category, even though they're not primary producers of PFAS. And then the multiple destruction technologies that I've listed here. Okay, so even prior to developing these methods, though, PFAS emissions were hypothesized and possible atmospheric transport, oxidation, and depositions downwind of a specific emitting source were modeled using computational models like CMAC and AirMod. So here we're showing a fluoropolymer manufacturing facility emitting, and then different options for deposition downwind. And then we started to see studies like this one in Science in 2020, where some of our EPA colleagues detected PFAS in the soil around a PFAS manufacturing facility in New Jersey. And then when they looked at the geographic distribution of the compounds around that facility, they saw that the distribution more followed a wind or an airborne transport pattern rather than any other route of contamination, like following surface water patterns or something like that. So that's really interesting, and it further highlights the need to have methods that can directly measure what is being emitted and how much, rather than having to do a kind of educated inference after it's already been settled down into the soils. Okay, so you know, PFAS air emissions. So we've established that PFAS air emissions. We want to measure them, and we really want that information right now. Oh, and I should point out. So Troy was right. You know, I am in ORD. We are publishing methods, but the vehicle that we're using to publish these methods are actually through the Office of Air, so OAR. And through specifically the Office of Air Quality Planning and Standards. So they release these methods called other test methods, or OTMs. They're formal methods supported by field and laboratory data, but they're not required to be subjected to the federal rulemaking process, which can take a lot of time. So for something like PFAS, where we want to be measuring them, you know, some people say we want to be measuring them yesterday, then this is a really great way to do that, to release a method as quickly as possible. So effectively, we generate as much early data as we can, then we write a method using the best practices that we know at that time, and we release it for the measurement community to use. And then we start to see the results of more and more of these tests. And then we have the option to revise the method if necessary. And again, that doesn't have to go through the federal rulemaking process, so it's relatively easy. There are a lot of advantages to this. For one thing, it gets everyone in the measurement community kind of speaking the same language. And it also promotes consistency in measurements. And so if the community kind of coalesces on one method to use and improve, we'll get to the end goal of having the best possible method much quicker than if everyone's kind of doing their own thing. So yeah, so I'm a big fan of the OTM. Okay, all right, let's get into it now. So I checked this morning actually, and right now there are 14,735 PFAS listed in the most recent list of structures on EPA's Tox Chemicals dashboard. So that presents a problem for the measurement community because generally with sampling and analysis procedures, you try to match the appropriate technique for the chemistry of the compound or the compounds you're trying to analyze. But because there are more than 14,000 of these things, they all have different chemistries that span, the whole chemical space. No one sampling or analysis approach exists that will characterize all of them at the levels desired. And I'll put that caveat on there because Troy did talk about total fluorine methods, but many of these compounds are we want to detect at such a low level that those techniques are not achieving that level of sensitivity. So we knew we need multiple approaches, and we developed two that are in the solid circles here, and then working on the third. And I've broken them out on this plot here with kind of increasing volatility on the y-axis and increasing polarity on the x. So there's 4 quadrants, but only 3 methods. We're currently not prioritizing the top right of the polar volatiles. Excuse me. That's really just the ultra short chain compounds that Troy was mentioning. And there's only a handful of those. Eventually we'll get there, but our priorities can lie elsewhere right now. So let's start with the first method we released, OTM45, which was developed to characterize the polar semi-volatile PFAS. Okay, so if you're wondering what polar semi-volatile PFAS are, they're probably all the compounds that you're most familiar with. There are 49 targets for OTM45, which are located here in the table on the right. And so we released this method originally in 2021. Like I mentioned, people started using the method. We heard a lot of feedback on what was working, what could be improved, and I'll talk a little bit about what we revised on the next slide. But one thing I want to say is, these compounds, while we're all these are the ones that we're familiar with, the polar semi-volatiles, because these are the compounds that are targets in a lot of the methods that Troy already mentioned, the drinking water methods, the 1633 as well. And so we really had a leg up when we were developing this method that analytical finish, the LCMS, MS conditions were really well characterized and established. So we didn't reinvent the wheel. We really borrowed from that existing body of knowledge for the analytical finish for 45, and then paired it with a sampling methodology, EPA method 23 for semi-volatiles and particulates, and found something that would work for this class of compounds to collect them from source air emissions. And then an important point that I'll talk at the very end about the pre-sampling, pre-extraction, pre-analysis isotopes are very, very important to have confidence that at each step of the method that you're not losing track of any analytes or any labeled isotopes. Okay, and then the last point on this slide, I bolded 4 compounds here: PFOA, PFOS, PFNA, and HFPODA or Gen X. I just wanted to highlight those 4 compounds in bold because a little less than a month ago, 3 states, North Carolina, New Mexico, and New Jersey, which I believe is a NEWMOA state, petitioned the EPA to add these 4 to the Clean Air Act list of hazardous air pollutants. So, really paying attention to that, and that, I guess that's on the administrator's desk right now. So that'll be interested to see what comes of that. But all those 4 are targets for OTM45 and would live in that polar semi-volatile space. All right, so this is just a picture of the OTM45 train in action in the field. I mentioned the revision that was released earlier this year. One of the things we had questions about using Teflon or other fluorinated material in the sampling train. That's pretty standard for a lot of non-PFAS methods, and sometimes there's no real good replacement. And in that case, we just issued guidance on how you can best characterize what could possibly leach off that Teflon material, run blanks, additional blanks to make sure that it shouldn't compromise your sample, do a proof blank train. And then probably the major modification was improving the robustness of the XAD extraction and concentration procedure. So when we started seeing some results from these field tests, it seemed like really wet stacks or wet sources where it saturated that XAD seemed to interfere with some of the concentration steps. And we had trouble recovering some of the longer chain acids and other PFAS. So we evaluated a solid phase extraction approach, and that seemed to work really well. So we put that in the text of the method. It is a performance-based method, but we wanted to feature something that we had confidence it would work well. And it also has an added benefit that it seemed to show that it removed other chromatographic interference. So, you know, whereas we were just kind of blowing down, evaporating solvent prior and concentrating everything, including some of these interference, it seems like the solid phase extraction is actually removing some other compounds that are not in our analyte list, not necessarily fluorinated species, other things that would be collected on the sample. And then we wanted to, and another major effort was to revise the list of the compounds and the surrogates to align more with what's available with 1633. That's just kind of saving the laboratory time and money, where they're not having to mix up different standard isotope mixes for every different method that EPA puts out. So trying to throw them a bone there. Okay. So when would you use OTM-45? So I found this photo on Brown and Caldwell's website, their firm, and this is showing a furnace. You have some influent of PFAS, and then a furnace, a destruction technology, and then all the options for PFAS output. But we're not limiting ourselves to just talking about destruction technologies, which I said in the morning. So I modified this figure a little bit. So any type of source. So we're talking about the industrial sources, where it's the chemical production plants, or the the users, where they're maybe coating a fabric or a consumer product in a water resistant or stain repellent fluorinated coating, you know, using those materials in a thermal process, or a destruction material. So they could all have these types of outputs as well. So when do you use OTM-45? What types of compounds are you trying to detect? Again, it's going to be those unchanged species. So you're going to have those polar semi-volatile compounds that you're very familiar with. And because this is a targeted method, like Troy was saying, we are only really looking for those 49 target compounds, and those would be the unchanged ones, whether they're being emitted, getting past some emissions controls from an industrial source, or being ineffective destruction technology. So these are basically points to saying what I just said. Known PFAS compounds of concern, replacement and emerging industrial compounds. And then if you did want to look for something other than those 49 targets, that would require an additional non-targeted analysis, which again Troy mentioned. But yeah, that goes outside the scope of OTM-45. It can be done, but the method doesn't give any guidance on that. So that would be a limitation of this particular method. Okay, so back to the quadrants here. So we'll move on from OTM-45 to the next method that we released, which is OTM-50, and that is canister sampling for non-polar volatile compounds and a GCMS analysis. We have 30 targeted fluorocarbons, and they're primarily known products of incomplete combustion, but some industrial PFAS as well. Okay, so here's here on the right is the 30 targets for OTM-50. You can see all the way down CF4, which is the numbers on that figure are just how many carbons are in that molecule. So C1 compounds up to C8, and then some fluoroethers. So we released this in January of this year. Like I said, it uses canisters to collect the sample, and then we, instead of analyzing by LCMS like OTM45, we're now using a GCMS because these are generally gas phase species and volatile compounds. And if you're familiar with the method TO15A for like air toxics, it requires a lot of the same equipment, sampling and analysis equipment. You'll need a pre-concentrator just like TO15A. But that's a benefit that you don't need to probably acquire new equipment if you're already doing air analysis. You can just repurpose that. So, oh, and then again, I highlight that it's mostly products of incomplete combustion, but there are certain industrial compounds like HFPO, which is hexafluoropropylene oxide, which is the precursor to Gen X, synthetic precursor to Gen X, tetrafluoroethylene, which is the monomer of PTFE, and then E1 and E2, which are decarboxylated HFPO dimer acid and trimer acid, respectively. Okay. And then this is a schematic of the sampling train, and then again, it in action in the field. There's a hot box and a particulate filter upstream of the canister, as well as impingers that we include whenever there's high moisture content in the stack, because you don't want that to go into your can, or acid gas. And specifically, we're talking about HF, especially when you're sampling at a destruction facility where their goal is to drive formation of HF. You don't want that to get in your canister, so it'll be neutralized in the or captured in the DI water impingers before getting to the canister. Okay, and then one really cool thing, you know, like I mentioned, a limitation of OTM45 was that you don't see, or you won't know anything without doing NTA about the anything else other than the 49 targets. For OTM50, we included something called an unknowns analysis. So we did our best. All the 30 targets were actually, that target list was built out from real samples that we collected and identified compounds that were being emitted from those sources. But we know our target list isn't exhaustive. So we leave some room to ID new targets. So you may be familiar with other methods that have what they call a tick analysis, or a tentatively identified compound analysis. And we're very careful to distinguish what we're doing with the unknowns analysis from that tick analysis, because the tentative identification usually requires a confidence, a quality match to an existing library spectrum, like a NIST reference spectrum, or a Wiley, or any other commercially available GC mass spec spectrum. But because we're dealing with kind of emerging contaminants and new things that maybe people haven't looked for, a lot of the stuff that we're really interested in are things that will not have a library reference match. So we don't want just the things that are 80% or higher. We're actually more interested in the things that are really low matches. So regardless of quality match score, we're doing unknowns. We're not making any identification. We're just providing that data, because in other environmental methods, if it's not a target compound, it's almost like it never even existed. That data is just ignored or discarded, or not even really included in any report. But for OTM50, you'll at least know there were other things present in that sample through the unknowns analysis. And if you get a sample that you're really interested in identifying what that is, you have the option of, or you may pursue that, because the canister, it doesn't consume the entire sample in one analysis, you can find a high resolution mass spectrometer to try and get an accurate mass and figure out what that is. And just the EPA, you know, if we start seeing some of these compounds occurring over time, that would definitely be a candidate for you know, a future revision of the method, adding those compounds in as targets. And the last point is, we're not specific for fluorinated species. You know, we're not saying only report anything with fluorine in it. You know, you're reporting everything. But so in that sense, that, you know, if there's the next emerging contaminant, even if it's not fluorinated, we may be able to see that as it's occurring or starting to become persistent in our environment. Because, you know, we do know that as some of these compounds start getting regulated, especially if we're regulating on a compound by compound basis, industry may just pivot to alternative compounds or alternative chemistries. So we want to have methods that may see those compounds as well. All right, now it's time for the poll question in my part.
Okay, let's see here. Poll question.
Poll question.
For a given source, what PFAS output options may OTM 50 help assess? Those that pass through unchanged, partial transformation or reformation, mineralization, all of the above, or just, well, A and B would be one in the first and second. So we'll let this one stay open for a little bit longer. Please vote. Let a few more people do it here. And okay, I'm gonna close this, and actually the answers, I don't know. Let me see if I can show, share. Did show. Okay,
Oh.
Stephen, I don't know if you can see that, but
I cannot.
there was, answers were spread across. So 10% said the unchanged, 15% said the partial transformation or reformation. Nobody picked mineralization, but that's definitely correct. There was all of the above, so that would include mineralization, or that both A and B. So which
Right.
one's the right one?
So yes, so the right answer, I think I'm going, it would be I think it was B, both A and B. So A and B would be the unchanged and the partial transformation or reformation. So it wasn't it wasn't a layup question, but I'll try to explain why. And so if, say you were an industrial source and you were manufacturing PFOA or PFOS or Gen X, those polar semi-volatile compounds that we know, that we're very familiar with, but you have some sort of pollution control. In that sense, yes, OTM 50 would be looking for degradation products of those larger PFAS compounds, because these are smaller than those polar semi-volatile species. But as I mentioned, with HFPO, TFE, tetrafluoroethylene, and all the ethers that are industrial compounds, synthetic precursors, they are being produced by these manufacturers. In that instance, you may want to use it as like maybe emissions that are getting by from the controls that facility has when they're synthesizing those specific compounds. So you could be looking for, there are industrial targets in OTM 50 that you can be looking for unchanged species, not destruction or controls. But then I think most people or most of the targets are still products of incomplete destruction. So a little bit of a tricky question, but I really wanted to highlight that, you know, you can be using OTM50 for industrial emissions, and I'll just say as an aside, you know, our detection levels are really good, and so really low. So if you you know, we already have some people asking about maybe fence line monitoring or doing, you know, because I said it, how similar it is to TO15A, which is an ambient monitoring approach that, you know, could we possibly do something similar with OTM50, you know, without you know, putting it directly into a stack, and I think you could. Our detection limits are low enough that you know, fence line or ambient are in the ballpark. So anyway, thanks for participating in that poll. Okay, again, I forget that I had these bullets, but yeah, all the take-home points for OTM50. Okay, so back to the quadrant, and we're gonna finish up with the non-polar semi-volatiles, which right now we are saying the approach is method 0010, which, you know, these are SW846 methods that Troy highlighted, or he didn't highlight these methods, but they are in that compendium. Method 0010 sampling with an 8270 GCMS analysis. And we're really interested in a target analysis for fluorotelmer alcohols and select 8270 semi-volatile non-polar species that could be potential products of incomplete combustion. And so why? So we want a method for fluorotelmer alcohols. I think I already wrote down a note based on Troy's talk to reach out to Gene Van Buren about this to make sure we're working side by side on this. But we're really interested in this fluorotelmer alcohols because as this graphic I stole from this paper shows that fluorotelmer alcohols, through atmospheric transport, they can just be oxidized in the atmosphere and to the corresponding carboxylic acid. So, you know, if you have an 8,2-FTOH, that could transform into PFOA, which we know is problematic. So we want to be able to measure fluorotelmer alcohols before that they you know, can travel downwind and oxidize. Along the same vein, or a slightly different vein, but still a non-polar semi-volatile compound class of compounds of interest, is we want a method that would characterize potential products of incomplete combustion or destruction of concern. So you may not be able to see this little schematic in the right. It's pretty small, but I put this here. This is another graphic I found that is demonstrating that the science that we know from combustion, you have the possibility to form both PAHs and polychlorinated aromatics, even and dioxins. So, and that's with chlorinated species in the mix. So a different class of halogen, and we know all those compounds have adverse health effects. So, you know, but no one's really studied that for fluorine yet. But here we are introducing fluorinated material into our waste processes, just like we did chlorinated material. So if we had the possibility to promote formation of PAH due to improper incineration conditions or destruction conditions, or some sort of fluorinated analog to dioxins, we definitely want a method that would detect those now instead of, you know, 15 years in the future. So that's the motivation for that aspect of the semi-volatile, non-polar semi-volatile method. So the approach we're going to take is, again, similar like OTM45, you know, taking methods that we think would work for this chemical space and putting them together for a source method. And that's 0010. 3542 is the extraction method, and then 8270 is the analysis on a GCMS for PAHs and other semi-volatile compounds. But like I said, we think that these fluorinated compounds would still be in that chemical space, but now we just need to look for them there. Okay, and then in the just to highlight or point out that all these methods are important. Earlier this year, the destruction and disposal guidance that EPA put out in Appendix A, when we wrote guidance on how you should conduct emissions field testing at thermal destruction sources. All three of the methods I talked about today, 45, 50, and then 0010, 35, 42, 8270 are all laid out as important to do those methods for their respective targets, because like I said, there's not one method that's going to measure all PFAS coming out of a source, possible PFAS coming out of a source. So just to keep with the theme here, so the non-polar semi-volatiles, again, it's probably mostly relevant for when you're dealing with a combustion source, especially if you're looking for those PAH-like things. But when we start talking about the fluorotelmer alcohols or other semi-volatile PFAS, that they would still have that importance when you're looking for emissions from a source without controls or with insufficient controls or improper destruction. And one thing, like OTM 50 and we do want to be mindful of looking for unknowns. And that kind of gets me to OTM 55. So, you may have heard of OTM 55, may have heard me talk about OTM 55, and you may be thinking, why am I avoiding saying OTM 55 until now? Because, it doesn't exist yet. We're working on it, right? That you saw in the guidance that we went to great lengths to, spell out all the different SW846 methods that you would use, 0010, 35, 42, 8270. That we do believe that right now, or we think that OTM, or no, I guess is what my slide says, that OTM 55 will be, those will be the framework of OTM 55. But, we were just, my colleague Jeff Ryan and I were just looking at 0010 the other day, and we're like, oh, well, we would want to modify this, and this when we write OTM 55. So there will be some modifications. We're not quite sure what those are. Or all of those are yet. We will have an unknowns analysis, and we will, require pre-sampling, pre-extraction, and pre-analysis surrogates. Some things that we're still trying to figure out are the target lists, how we're going to quantify. Isotopes, labeled isotopes exist for fluorotelmer alcohols. So, an isotope dilution approach would be ideal for those, but they don't exist for some of the products of incomplete combustion or destruction. So how are we going to do that? And then we've also discussed about doing a sequential extraction, since the trains are very similar between 45 and 55. Would it be feasible to do a non-polar rinse of the XAD and followed by a polar rinse to get everything all in one? And we just don't have data to support that yet. I mean, it's something we're definitely going to look at, but I think it's going to take longer to really thoroughly convince ourselves that that won't compromise OTM 45 sampling, which would be, not great. So yeah, the first pass of OTM 55 probably will not have a sequential extraction if I had to look into the future right now. But the point is, we're advising, and in the guidance, we are advising people to do 0010, to do this analysis. It's very important that we be looking for these things, and that data from these early experiments will largely inform what the end result of OTM 55 or the initial result. Like I said, these are OTMs that will be revised, but we do need more data at this time before we can release the method. And then finally, like I teased, just quickly touching on other non-traditional sources. So I'm getting also getting this question a lot. I have this graphic from a paper that out of the University of Florida that I like recently, where they're sampling landfill gas prior to going to the flare, where they were using similar methodologies to our methods with the XAD cartridge. But so the point being, you know, even if you have a non-traditional source where you have a low flow, or it's a pilot scale where you don't have the flows required for OTMs, that they may not apply directly, but the principles and sound measurement and analysis do. So, you know, the idea that you need to use the right sampling methodology, the right extraction methodology, and the right analytical methodology for the types of compounds that you're looking for still definitely stands. You definitely want to keep using pre-sampling, pre-extraction, pre-analysis surrogates. And the last point is these methods, these OTMs are releasing are performance-based methods. So they're designed to where the QA/QC guidelines are the backbone of the method, and we allow deviations. You know, this is essentially a deviation from the method, but the QA/QC guidelines, if you try and follow those as closely as possible, even for non-traditional sources, those should tell you whether or not you had a successful measurement or not. So yeah, there's a lot to unpack there, but this is definitely something we get questions about all the time. And then just to wrap up, you know, these methods are needed for multiple sources. We still need access to sources to evaluate methods. So if you ever have a testing opportunity, please feel free to reach out. And that's it. I think it's 3:01. So hopefully people can hang around for questions.
I didn't want to cut you off, so thank you so much, Stephen and Troy. And if people can stay for a few minutes, we can do some of the questions. But I think I'll let the Mass LSP folks sign off if they can't stay, and you'll still be able to get your credits. But if folks can stay on for a few minutes, we can do some questions. So. And what would I pick for questions here? So I guess the big one that I have is, Stephen, you know, people want to know about being able to incinerate waste. When are we gonna, is there a time frame for getting this all sorted out? And
yeah, so I mean, when can we incinerate waste? Well, you know, I guess maybe I should pull up my disclaimer slide.
I mean, if we determine, like, when are we going to be able to determine whether it's okay or not? Yeah.
Yeah, I mean, we are doing field tests, you know, with all these methods, and that's really what's driving it. We did a field test at a municipal waste incinerator earlier this year in Florida, and you know that went well. You know, we can't make conclusions based off of one test by any means, but you know it went pretty well, and definitely showed us or showed that, you know, we are capable of doing this, and that is how we need to proceed doing more and more tests. But you know what we've really learned with all of our work right now is that there's not, and unfortunately, I mean, I don't think I'm the only one to say this. There's, you know, people want a time and temperature and maybe a turbulence. Like if you hit this, you're destroying PFAS. But that's not going to happen. Or, you know, in my opinion, that would be not an appropriate thing for EPA to do, because every incinerator is different. So you know, even someone with at a given temperature, you know, maybe the waste stream doesn't see that temperature for as long as another, you know. So really it's going to require, in my opinion, I think each incinerator or destruction technology should demonstrate for themselves and not be taking parameters from another facilities test. I think it's got to be demonstrated for each individual one, if it was up to me, which it is not. So that.
Is EPA developing a test method for these non-traditional sources? And will there
that's
be
something
one?
that I'm talking to a lot of people about, and we, I wouldn't mind doing that. I'm pretty focused on 55 for, the traditional source, finishing that out right now. But, well, here's something that not a lot of people don't know. EPA doesn't have to be the one to write OTMs. Other people can write methods and then send them to us, and if they're good, they can be posted and developed by other parties. So that's something I'm talking to a couple of people. Like I mentioned, that landfill paper was from the University of Florida. I had some comments about ways that they could improve their sampling by using those pre-sampling surrogates, or more effectively doing some of that QA/QC criteria to make it more confident in the measurement and the result. So I think we'll get there. It may not be me or my group at EPA publishing those methods, but I think there's so much interest in that there will be more papers and more strategies coming out very soon, especially with like all the CERTA ESTCP destruction. They're all, they're not going up to full scale yet. They're all kind of demoing it at pilot or bench scale, and so they're trying to measure these things at smaller volumes.
I got one more for Stephen, and then there is one for Troy too. So hang in there, Troy. So could Stephen please elaborate on whether the method used to identify non-targeted analytes used in OTM 50 can also be applied to OTM 45 and non-air applications of method 1633?
Oh, okay. Yeah, that's a great question. So the very short answer is no. So then the big difference is the instrument that's used for those methods. So OTM 50 uses a GCMS, and 45 and 1633 uses an LCMS. And without getting into the nuts and bolts, GCMS is much better. The chromatography is much better, so you get better resolution of compounds. The LCMS really, especially for NTA, if you look at the full scan chromatogram, there is no resolution. You're really relying on software to deconvolute a lot of those peaks. So one of the requirements for, and one of the reasons we were able to include that in OTM 50 is because it can be done quickly and almost without any effort. So because contract laboratories are trying to do this, like, it shouldn't be any, well, I can say this, it shouldn't be much added cost per sample to do this unknowns for OTM 50. Now, if you're trying to, but the workflow, because it's so easy, and basically the software can integrate those peaks and spit out those reports almost automatically. We're just not there yet with LC NTA analysis. It still is very analyst heavy. It requires hours and hours of manual data review and stuff like that. So, we're not there. We're working on it, and every year, every month, innovations come on NTA, automated data processing. So that's the goal. We're pushing, but yeah, we have a benefit, and that's why I'm saying we want to do it for 55 as well, because that will be a GCMS analysis as well, not an LCMS. I don't have the answer for LCMS yet.
Okay, Great.
Okay.
So Troy, people are, and this was a question, this was a note I made myself too, is timeframes on some of these method developments that are happening, and particularly promulgating methods 1633 and 1621 as Clean Water Act methods. No timeframes.
I think the best thing you can do is to pay attention to reginfo.gov, and I was looking on there to see if the Clean Water Act, the Office of Water, has proposed those methods update there. But reginfo.gov is a place where EPA and other federal agencies are projecting the rules that they're planning on making, and I would say that's the best place to the most authoritative place to look as far as time frame for rulemakings go.
Okay.
But but I don't have an answer. I don't have an answer because I haven't searched reginfo.gov to see if anything is posted there.
Okay.
But that's where basically the federal agencies are communicating with the public about what they're planning on doing.
All right. So if it's not, how far out does RegInfo project?
I don't know. It might depend on how early they're. I don't know. What the time frame is that stuff gets added there before it gets proposed. But I know the PFAS, the 40 CFR Part 261 Appendix 8 rulemaking I was talking about for adding PFAS as hazardous constituents to RCRA. That was in reginfo.gov well before the proposed rule was released. Months before. So I think it may depend on the agency and the rule, but I think that information you might find there in advance of any proposed rule being released.
All righty. Well, we are more than 10 minutes over. So there were some other questions that came in that are more related to PFAS and use in consumer products. And that's really not what Troy and Stephen, are focused on. They're developing analytical methods, not necessarily doing the testing of different products and developing lists of what does and doesn't have PFAS. So, I guess one last question would be, and maybe you already sort of covered this and I missed it, but Stephen, about using methods for just ambient air.
Mm-hmm. Yeah. Again, I get this question quite a bit. I'm not working on the ambient air method, but if I was trying to develop one, I do have ideas on what I would try, and it would be very similar to the approaches we've done for the source methods, which is really look for methods that already exist. So I think for ambient air, what you're most concerned about are those compounds that we know have adverse health outcomes, or for instance, the 4 that were asked for the EPA to list in the Clean Air Act HAP list. So those all have really well defined LC-MS, MS analytical conditions. So getting it into using that, that's already really well established, and then maybe like a high vol sampler or something on a puff XAD that we know how to extract that with basic methanol, which would remove those PFAS, because that's what we use for OTM-45 to remove from the XAD. So really just looking at what we already know works and just applying that to a different system. But again, pre-sampling surrogates, QA, QC, like all that stuff is, just very important in terms of validating whatever approach, especially if it's an untried, untrue approach. Like all those QA, QC criteria are there to show, to demonstrate confidence in the measurement.
All right, well, I think we're gonna have to really wrap it up this time. I'm not gonna ask any more questions. Thank you to everybody that's hung in there. Quite a few, at least over half or about half the attendees are still here, so that's great. So thank you, everybody. Thank you so much, Troy. Thank you so much, Stephen, for imparting so much information to us today. I will get PDFs of their presentations and I will post them on the NEWMOA website. And then after that's done, I will send an email out to everybody that was on the webinar today. So thank you again and enjoy the rest of your day. All right, bye-bye.
Thank you. Thank you.
Great. Bye, guys.
Thanks.